This will be a quick practice. There are three problems here for vectors, and I'm going to go ahead and post the answers. So if you want to, you can pause the video once you see the problem, work it out, and if you get the right answer, you don't have to worry about that part of the question. Or if you still want to see the way I work it out, you're more than welcome to. You can skip to the other problems if you like. This is just for your practice. So for the first problem, a car is being pulled out of the mud by two forces that are applied by the two ropes shown in the drawing, over here and over here. The dashed line in the drawing bisects the 22-degree angle. This is 22 degrees. The magnitude of the force applied by each rope is 2200.0 newtons. What is the magnitude and direction of the added vectors? So this is asking you for the resultant vector. And so in this case, we need to break apart each one of these individual non-perpendicular vectors into its perpendicular components. And the way that looks would be like this. I'm going to work with the first one that's on top. And so, let's say it looks a little bit like this. Its horizontal component is going to look like this, and vertical component will look like this. Now, we know that this is 2200 newtons. And we know that this angle here, if we look over here, this total angle is 22 degrees. So the bisect of that is going to be 11 degrees. So we know that we have 11 degrees here. And so now we can find the x and y components because we have the hypotenuse and we have the angle. And so the way this will look, we want to find the x component, we want to find the y component. The x component is going to be over here. This is going to be the adjacent, and so this is going to be using cosine. And so it's going to be 2200 cosine of 11 degrees. And that, your calculator should give you 2159.6. So that's going to be 2159.6 meters. And for the y component, that's going to be over here. That's going to be on the opposite side. So we're going to use our sine function. So this will look like this. 2200 sine of 11. And this will give us 420 newtons. So this is for the first vector. For the second vector, we do something similar, but we need to pay attention to the direction. So the second vector looks like this. And the horizontal component should go over here, and the vertical component should go over here. Now, as a quick note, we need to pay attention to our positive directions. It's going to be easiest to work with to the right as positive. And now, since we've already done this one over here as positive in the y, we've set our upward direction. So we've set up as positive and to the right as positive. So now we know that when we find our y component over here, since it's going down, it's going to be negative. So let's go ahead and label this one as well. So we know that this is also 2200 newtons. And our angle here is the same as before, as over here. So it is also 11 degrees. And what you'll find is if you work it out like this, like the previous problem, we get the exact same numbers as before that our calculator gives to you. And so we can look at this as 2159.6. And in this case, if we look at this, your calculator would give you 420, but because it's going down, we know it's going to be negative 420 here. Now, what we need to do is we need to add up our x's and our y's. And so now we do our final x and final y. We have 2159.6 plus 2159.6. And then we have 420 minus 420. And so what we get here is, from our calculator, 4319.2 newtons and 0 newtons. So in this case, if we are asked for the final resultant, what is the magnitude and direction of the added vectors? In this case, we only have an x component because our y component is 0, and with significant digits, we have a total of 3 significant digits, 22.0 and then 2200.0, so we use a 3. And so this becomes 4,320 newtons going east. And there you go. And the answer here should have also had east. Now, for the next problem. On takeoff, an airplane climbs with a speed of 120 meters per second at an angle of 28 degrees above the horizontal. The speed and direction of the airplane constitute a vector quantity known as the velocity. The sun is shining directly overhead. How fast is the shadow of the plane moving along the ground? That is, what is the magnitude of the horizontal component of the plane's velocity? If you've already done the previous problem, this one should be relatively easy. So let me go and just draw a quick vector diagram. If this is our velocity, and let me go and label this. So this is going to be 120 meters per second. And let me go and draw out the horizontal and vertical components. So we have our horizontal component here and vertical over here. We are told that the angle here is 28 degrees. So we have this as 28 degrees. And so in this case, all we are doing is looking for the horizontal component. So we just need to find our x. So in this case, we have 120 as our hypotenuse. We have 28 degrees. So we're looking for our adjacent leg. And so in this case, we're going to be using cosine. So we do 120 cosine of 28 degrees. And that should give you 110 meters per second. And in this case, we know that this is going to be along the x, so we could go and say east if we wanted to. And that will be our vector quantity. All right, the third problem. An observer whose eyes are 1.92 meters above the ground is standing 31.0 meters away from a tree. The ground is level, and the tree is growing perpendicular to it. The observer's line of sight with the treetop makes an angle of 16 degrees above the horizontal. How tall is the tree? So let's do a quick drawing so you can see what this looks like. So let's say that this is our ground, and let's say you are over here. So you are over here, and your eyes are here. Now, what we are told is the distance from your eyes to the ground is 1.92 meters. And you are looking at a tree. So let's draw a tree. And let me go ahead and move some of this down a little bit. All right. Now, what you're told is from your eyes, you see the top of the tree, and this makes an angle of 16 degrees. Let me go and draw the vertical component as well. This makes an angle of 16 degrees here above the horizontal. So this is 16 degrees. Now, you are told that you are standing 31 meters away from a tree. In this case, this horizontal component is 31.0 meters. And so what you're asked to find is the total height of the tree, so from here to here, based off of this measurement. Using your line of sight, this hypotenuse, we know that's 16 degrees, and knowing that the horizontal component of that is 31 meters, we can find our y component. That'll be from here, from your eyes to the top of the tree. From there, we just need to add the 1.92 meters, and we'll be good. So let's give this a try. In this case, let me redraw the triangle. So for this triangle, it looks roughly like this. We know that this is, that is not what I meant to do. We know that this is 16 degrees, right? Yes, 16 degrees. We know that this is 31.0 meters. And using this, we can find our y component. In this case, we have our angle. We're looking for opposite, and we have our adjacent. So we need to use tangent. So let me move this a little off to the side. And so, let me just go and write this out. tangent of theta is equal to opposite over adjacent, TOA, T-O-A. All right. Now, we can rearrange this. We're looking for our opposite, so this becomes A tan of theta is equal to opposite. And so, 31 times the tangent of 16 will give us our opposite, the y component. This will give us 8.889. So we get our y component is equal to 8.889. Now, to this is not our answer yet, and this will be in meters. For this, we need to add the 1.92 meters, because that's how high up our eyes are. So we do plus 1.92, and this will give us, with right number sig figs, 10.8 meters. And we are good. And so it is 10.8 meters tall. All right. And there you go. If you have any questions, we can address these in class. There will be more practice in class.